Okay, so let's talk about how to measure the variation. So let's take, suppose we have two data sets. A looks like this, 0, 0, 0, 50, 100, 100, 100. And let's say B is a different data set. 0, 50, 50, 50, 50, 50, 100. So what is X bar for A? What is X bar for A? So if we look at these numbers, I think we can see that the zeros kind of balance with the hundreds, and so the average is going to be 50. You can check that manually. And then let's do the same thing for X bar B. So what is that? So again, we can see that like all these are 50 and that this 0 balances with this 100. And so this is also going to be 50. So they both have the same mean. They both have the same mean. Oh, I'm sorry, I forgot one more. I want to have one more in here. And that's going to be C. And that's going to be just 50s everywhere. Okay, so also X bar C is also 50. Okay, but I don't, there's some major differences between A, B, and C. Just because they all have the same mean doesn't mean that the data sets are the same. And there's some significant differences between them. So what's the variation in C? Well, there's no variation in C, right? Everything is exactly the same. They're all 50s. Now, what about the variation in A and B? So which one would we say is more varied? Well, for B, we can see that almost everything is right in the center. Almost everything is the same. Almost everything is 50. And there's just a little bit of variation from 50 on the first element, and the last element are the only elements that have any variation from 50. Whereas here, the first three elements vary quite a bit from 50, and the last three elements vary quite a bit from 50. So we would say that there's no variation in C, and then there's less variation in B than there is in A, and A has the most variation. Okay, so we come up with some ways to measure the variation, and the first one is the simplest way, and that's called the range. And that's just equal to the highest value in the data set minus the lowest value in the data set. So in C, so if we write like range for C, I guess I could write it like that. The range for C, what's the highest value in C? It's 50. And what's the lowest value in C? It's also 50. So the range is 0. Okay, now we can also do the range for B. So we ask what's the highest value? It's 100. And what's the lowest value? It's 0. So the range is 100. And then, of course, we could also do the range for A. And what's the range for A? Well, the highest value in A is also 100, and the lowest value is 0. So the range for A is also 100. So that's what we mean by the range. It's the highest value minus the lowest value. And that tells us something about whether there's variation in the data set, because it distinguishes between this one and this one. Even though these two have the same mean, the range will tell us that the variation in B is much bigger than the variation in C. In fact, the variation for C is 0, and the variation for B is not 0. It's 100. So it's much bigger, the range. So the range does distinguish between C and B in terms of variation. So that's good, and it's very, very simple to calculate. You just take the highest value minus the lowest. However, what about the difference between B and A? Now, we said we really think that B is less spread out than A, but the range doesn't tell us that. So the range doesn't quite work in all cases. It's not really sensitive to the difference between B and A. So whereas the range is really simple to calculate, it may not be the best measure of variation that we can come up with. So let's think about how we can distinguish between B and A.